This is a brief video on how to calculate regression lines given a particular data set. This is a data set that we collected in class. I have plotted all of these data points, and you can see this on the calculator. You guys did this on your sheet of paper. You can see that it kind of looks as though it curves just a little bit. So my guess is that it's probably not linear, and it might be something like exponential or quadratic. So the first thing you have to do is sort of identify which type of function that you're going to be working with, which is often done through a graph. Now, once we have our graph, really everything else from here is going to go through the stat key, since we're dealing with statistics. And we're going to enter our values into list 1 and list 2. So the x values go in list 1 and the y values go in list 2. Once we have our data entered, we will again go into the stat key, and this time we are going to calculate. Like I said, you have a whole list of opportunities here, or options, and since we kind of looked at it and it looked curved, the first curve that I see here is quadratic regression, so this is what I'm going to run. So I'm going to run a quadratic regression, and now I have to tell the calculator where it's getting the information from. So I'm going to tell it that it's getting the x values from list 1. The comma breaks each of the commands, so I'm going to tell it that it's going to get its y values from list 2. And this is optional, but this is for part 2 when we start predicting. So if you watch this part and the next part, you'll see why I'm going to do this. But I'm also going to go into variables, and I'm going to go to y variables and y1. And what I'm telling the calculator to do is to take the regression model and store it in my y equals key. So it's actually going to create the graph. So once I run this, this is my particular model. And you can see that it tells you that this is going to be in standard form. It gives you the a value, the b value, and the c value to fill into that equation. The r squared tells me that it is a very good fit for my model. Now, it might not be the perfect fit, but it is a very good one. So you, again, want to run regressions for all of the different possibilities and see which one is the best model. But for this example, I'm just going to go with this, and my final equation would be y equals 0.105 x squared plus 0.037x minus 0.17, which you can see from those a, b, and c values.